Let me just start my slideshow here. Can you all see that?
Yes, I see it.
Yes.
Great. Okay. So we've had a bit of a discussion pre-call and decided that we're going to start with the remote ID discussion and slides, and then move on to the normal monthly partners call after that. There are some interesting things that have been happening the last month in our regular monthly update, and so please stick around for that at the end. But I suspect the majority of people here are here for the remote ID discussion. Feel free during this discussion to just ask questions and interject and things at any point in the discussion. So please don't treat this as like a formal call. We want to make sure that everyone gets all the information they need, given the very compressed timeline we're on to get support in for the FAA requirement. So I'd like to start off by saying thank you very, very much to all the people who have made the remote ID support in ArduPilot possible. In particular, Jeff has been working on this for years. So please go and have a look at what he's done on Wurzbach Electronics and have discussions with him about compliance testing and getting all this deployed. Josh Henderson has been doing a lot of work, particularly in the last couple of months, getting the PRs ready and support ready. David Buzz has provided a lot of support as well. Many thanks to David for the ESP32 help. And Roel Shiphorst from Bluemark, who's we've been having really good discussions with him about his remote ID module, and of course the Open Drone ID project, which has been absolutely fantastic. So jumping straight in, a basic overview of remote ID. As of September the 16th, 2022, standard remote ID is required by the FAA in the USA if you sell vehicles. The exact details around that requirement are in the FAA docs and some more in the means of compliance document. This link here, you should read as far as that requirement if you're selling into the US market. And this ASTM means of compliance document, you're going to need to buy a copy of that. It's $60 US. It's available now, and that means of compliance has been agreed to by the FAA, which means that is the easiest way forward to compliance. There are other ways to become compliant apart from the ASTM one, but by far and away the easiest path forward will be to follow the ASTM means of compliance. And again, many thanks to Jeff for his tireless efforts over many years to make that means of compliance possible. Basic components of that compliance: you need a compliant transmitter module, which will transmit Bluetooth and or Wi-Fi packets. Some more details on those packet specs and things later in the call. You'll need support in the flight controller firmware to be able to communicate with the transmitter module to set up all the required data that the transmitter module needs to transmit. You need support in the ground station software for the operator location and inputting all of the details of the flight. And you need to go through a potentially rather arduous certification process with FAA and FCC. The means of compliance document from the ASTM provides a lot of information on how you do that testing, in particular, how you get to the point where you can do what's called a declaration of compliance, which is where you sign off that you have done all the required testing. There's more information on that later in the call, and the expert on that area in the ArduPilot community is Jeff. So really detailed questions, you should be talking to Jeff. ArduPilot solution for this is based on Open Drone ID. Please have a look at the Open Drone ID website there at opendroneid.org. We have been using the Open Drone ID Core C implementation in our transmitter firmware. Basically we've been building upon the Open Drone ID solution. Members of the ArduPilot community have been involved. Tom was involved in certainly the early days of that when his time at Intel. But there's been lots of people helping to put that together. We've got a wiki page as of yesterday. It's just a skeleton page at the moment, but there'll be more information that will come into that based on these slides and you know, further developed over the coming days. Any questions on that initial sort of overview of, you know, what we're aiming for and the components that you need? All right, we'll move on then. So hardware. So you're going to need a transmitter module. And so there's several possible sources of that. The simplest way to get going right now, if you need to test this week and you want to start going towards testing and compliance, etc., the fastest method would be to get yourself one of these. This is a ESP32 S3 module, which I just got a note saying my Firefox that I'm presenting with is about to update itself. Okay, wonderful. So they're available very cheaply on Mouser and other places, and there's a link there to where to get one. It also should be possible on the right here, you see a picture of, this is the one from Bluemark. This supports both CAN and UART Mavlink. We've yet to test our firmware on this module. We're hoping to test that next week. Jeff is also working on a module, and I expect he will have details on that up on his website shortly. Otherwise, talk to Jeff directly about the modules that he's creating. As I understand it, Jeff is aiming to create both ESP32 and likely Nordic NRF modules for Blue compliance, US sourced parts. But I'm sure Jeff will give some more details on that. Or Jeff, do you want to speak to that at all now about what your plans are on modules?
Sure. So right now I'm planning to do an ESP32 module in the immediate term, and then as I can find and secure supply of the Nordic devices, I will introduce a Nordic-based device, and we'll go from there.
So Jeff, you haven't selected a Nordic device yet?
I have. It's an NRF 52840 is the most probable solution. There are some other items that are worth considering that are newer, but the most of the modules that I've seen that are going to meet requirements are based on the NRF 52840.
So, yep, going.
I'm sorry. Do you have a timeline on that by any chance?
Not yet. Right now, I'm trying to get the ESP device out over the wall, and then also get all the sort of paperwork side of this done, because there's the paperwork side to this as well as the hardware side. Okay. And also Nordic stuff is kind of hard to get right now in general, because it goes into so many devices that became overnight popular with everyone working from home and whatnot.
Okay, thank you.
So at the moment, the ArduPilot firmware for this, we've written a firmware for the ESP32, and it works, has been tested and validated on the S3. We expect it'll work on the C3. C3 is basically a single core version of the S3. The S3 is a dual core device. We expect it'll work on the C3. I should have a C3 in my hands in the next couple of days, and I'll be testing that, and it might be a slightly cheaper option. And the Bluemark device is based on the C3. So again, we're expecting to be testing that by early next week to hopefully validate that the C3 is all good. So I'll just show you roughly what I think we're talking about hardware. I'll just point my camera down to a test setup that I have on my desk, so you can sort of understand the various components. So can you guys see that on my video? I might even stop sharing and just show the video for a second. Can you guys see that?
Yep. Yes.
Yeah, see that okay? Okay, great. I'll just try and get the light a little better. Okay, so the test setup I have here, this is a Cube Orange, of course. You can recognize that. Then I have an ESP32 S3 here, and I have a 1 megabit CAN transceiver I'll just move this one out of the way. So I have a CAN transceiver here, which is plugged into a couple of pins on the ESP32S3. And out of that transceiver, there is a 4-pin JST-GH CAN bus connector, which is plugged into CAN 1 on the Cube Orange. And the Cube Orange has a GPS attached with an external antenna going up to my roof. So, and this system is up and running. So it's transmitting drone CAN messages between the ESP32 here and the Cube Orange over CAN bus. And it's transmitting MAVLink currently over USB to a MAV proxy implementation of the ground station. And I'll show you in a second the ground station running and the various CAN messages going through. The transmitter module here supports either connecting to the flight controller over UART with MAVLink or connecting to the flight controller over drone CAN. It actually does both in parallel, so you could actually connect both at once if you wanted to, and it would work. But I'm guessing that most people will pick either CAN or MAVLink. If they've got a spare UART on their vehicle, they might well choose UART. Otherwise, they'll plug into the CAN bus. So any questions? We've got some background noise there. If people can mute when they're not talking, be possible. I don't know whose noise that is.
I had a quick question.
Yes.
So the drone CAN implementation. So we are one of those people that we don't really have too many. We have 0 3 UART ports right now. So is the CAN version of this just also going to be plug and play? Will that involve an upgrade to a copter version or anything like that?
It will need firmware support because the drone CAN messages only got added a few days ago. We're on a very compressed timeline here because the ASTM means of compliance was only accepted by the FAA last week. So from that date, that's when everyone went go on the start line to getting an implementation and getting it out. So we got the go on the means of compliance last week. I released the first beta of ArduPilot Plane that supports these protocols, both CAN and MAVLink, this morning. I'm expecting a stable release of Plane within 2 weeks supporting this. Randy is planning to do a beta probably in the next few days of Copter. I'm guessing that we will have a new Copter stable 4.2 out again, likely within the next couple of weeks, depending on the testing results. But really, there isn't a lot of updates that need a lot of testing. So the main thing being added is Open Drone ID, remote ID support. Backports to 4.1, I'm expecting to do at least a 4.1 backport of this for patches for vendors who can't move to 4.2 rapidly. It's possible I might be able to do a 4.0 backport, but no promises at this stage. I haven't yet scoped out what is required to do that, but I'm fairly confident I can get a 4.1 backport done quickly. So yes, you will need an updated ArduPilot firmware, or at least patches to your existing firmware. And those patches will allow you to plug in this module on CAN bus and have that part. Remember, the transmitter module is just one part of the overall solution. You need ground station changes, you need ArduPilot firmware changes, you need the transmitter module, you need compliance testing, both FCC and FAA. So there's a lot of pieces to the puzzle that you have to all get together. And all of those pieces need to be in place to sell a product after September the 16th, next month. Thus this call to introduce people. But the compressed timeline, it's incredible trying to get all that done in like a month and a half, but it's what we're facing. So does that make sense?
Yes, thank you.
Yep. If you need help we've got the partner regulatory channel for partner questions. Please try and use the shared partner regulatory channel if possible, or the partners channel for questions, just because we're going to get a lot of partners asking about this and we don't want to answer the same question, 100 times. But if you need backports or, assist in adding the patches for a particular branch of ArduPilot, please reach out to us and I will do my best to get patches for your branch as quickly as I can. All right, so that's where we are as far as the hardware. I'm sorry,
another question. If you're going to use the drone CAN solution or the CAN bus solution, then you have to have a CAN transceiver just any off-the-shelf CAN transceiver will work, or is there a
It's just
specific
1
one?
megabit BX CAN. So I just got one off eBay that I use. I would expect that any 1 megabit capable CAN transceiver will work. The particular one I have on my desk is the eBay CJ-MCU 105 L, but I would be very surprised if you couldn't basically get any CAN transceiver and make it work. And so, yes, you'll need a CAN transceiver. Adding that on. So you could actually build your own transmitter module by taking an ESP32 dev board, adding a CAN transceiver, putting it in a 3D printed box and put a nice antenna on it. You can get versions of this dev board that take UFL antenna connectors. You're going to need a decent antenna setup. So you could roll your own that way. Just be careful about FCC requirements and the range requirements. You have to get good range out of this. So the board antenna that I have on this one, that little antenna up the end there, almost certainly won't cut it. You're going to need something a bit better. Again, for RF questions, that sort of thing, talk to Jeff, or you might well be able to use the Blue Mark solution. And you've also got to be concerned about the proximity of this to other radio emitting devices in your vehicle, because if it's within certain, what distance is it, Jeff? You've got, if it's within like 30 centimeters of another radio, you've got to do an extra FCC thing.
20 centimeters.
20 centimeters. Okay.
And,
so
and then you that's the threshold for co-located transmitter. And then if it's not co-located, then you can use modular, which is what the ESP32 comes with. So it's a lot easier if you can be more than 20 centimeters away.
Indeed. So yeah, so this all gets you know, a little bit tricky.
Trent.
Yep.
Just on the CAN transceiver, it'd be good if they used a 8 megabit, just even if this doesn't use that, just for future compatibility with Orange and some of the CAN stuff we're doing in the future.
Yeah, ArduPilot's moving towards FD CAN support, at least 5 megabit, preferably 8 megabit. If you can do that, great. But in the compressed timeline, the initial modules, I can imagine a lot of them will be using 1 megabit transceivers just for availability. But yeah, if you've got a particular transceiver you recommend, Philip, please put it in the partner regulatory channel. And I think that would be a very good idea for future compatibility.
Cool.
All right.
Can I sneak in a few questions?
Yes, of course.
So one question is there a definition of what you mean by the GCS? Does that mean the transmitter with the sticks on it? Or does that mean if you've got some other command and control computer, is that the GCS?
Very good question. You have to have something which continuously gets the operator location. You have to have a GPS basically on where the operator is. Whoever the operator, the pilot in charge, has to have a GPS at their location. And that GPS location, along with a host of other information, basic ID, operator ID, various pieces of various fields. I'll show you those fields in a second. That has to be transmitted to the flight controller using some Mavlink messages for that. And then that gets out to the transmitter module, which is then broadcast using the Bluetooth Wi-Fi broadcast packets. So I imagine a common setup would be people have Mission Planner. Mission Planner support for this. Yep. Mission Planner already supports GPSs attached. That will probably be the fastest way forward. But Jeff and I have been discussing ways of using a phone, because the part of the ASTM means a compliance testing, but actually, strangely enough, by the Forestry Service, showed that current models later than 2019 mobile phones are basically deemed to be compliant as far as the accuracy is concerned, because there's accuracy requirements for the positioning of the operator. And so a solution where you have an app running on your mobile phone, providing the position and all the information through to the flight controller, is likely to be something that's viable. Exactly how the mobile phone will talk to the up to via Mavlink to the flight controller. We're not sure yet, but you know, for example, I expect Mission Planner running on a mobile phone will do the job. I expect that HereLink, I would be very surprised if we don't get an update to HereLink to support this. You know, I could imagine that, you know, Philip and Michael are already thinking along those lines. And a screen in the HereLink display, we're filling in all your operator IDs and all those types of things, and then press the button and you're good to go. So there will be a host of ones. I know some of the ArduPilot partners have custom ground station interfaces. They run their own code. All you need to do is fill in the right Mavlink messages and send them. And as long as you're giving a good, you know, 1 Hertz operator position from a GPS, a decent GPS, then you're good to go. Where things get tricky is if you've been flying, for example, with a Tyrannus, just using 2.4 gigahertz AC and nothing else. In that case, you're going to need to change how you operate, because you need a way to get the GPS position of the operator up to the vehicle, in which case you might need to get creative. For example, maybe using something like a TX mod in the with the RFD 900X in the back of your Tyrannus with Wi-Fi connected to your phone. I suspect that might be a way forward, but I haven't tried. I have TX mods here and I could try that, but I haven't yet tried to develop that solution, though I expect that that would work. So you basically have Mission Planner running on your phone, talking to Wi-Fi to a TX mod in your Tyrannus, that communicating with the vehicle, and that then providing all the Open Drone ID messages from your phone via the TX mod over the RFD 900X 900 megahertz link to the vehicle, out to the transmitter module, and you're good to go. I would expect that would work, but I haven't yet demonstrated that end to end. I did the first flight with ArduPilot Open Drone ID on Sunday, so this is all very new. But that's where I think it would be heading. Does that make sense?
Okay, so yeah, I think so. So I would think that in our case, we have a companion computer with a Mavlink connection and also a you know, Wi-Fi to the ground station. And so we could, I imagine we could, you know, our custom software on the ground station says, yeah, we're good, and here's all the data, and that gets sent over by Mavlink. And then
sorry, go on.
Well, that leads into my other question is, which it may have already been asked, if due to the companion computer, if I'm out of TLM ports, can I plug in the ESP32 module as a USB device and forward the Mavlink over Mav proxy somehow? Or
yes, you could. You could indeed.
Does it have to be plugged in directly to TLM?
No, you could indeed do that. You could either use a USB serial adapter. So I've been testing my device against SITL with a USB serial adapter, and that works. But I could easily, if you need me to give you a version of the firmware for the remote ID module, for the transmitter module, that directly sends the Mavlink over wherever one of it's it's got 2 USB ports. It's got a USB UART port and a USB T2I ACM type port. Normally the second one is used for flashing. Then the primary is just a Silicon Labs USB serial adapter built into the dev board. I could trivially modify the firmware for you so that that USB port does the Mavlink, and you could probably then plug that straight into your companion computer and be good to go.
Oh yeah, that'd probably be useful.
So the real wild card in all this, though, is the tamper resistant requirement. It's the ASTM one. It isn't actually too bad, the anti-tamper stuff. It's basically, it has to have reduced chance of people tampering, right? So a USB cable going between the ESP32 and your companion, maybe that will pass FAA, you know, anti-tamper. Maybe it
won't. No, it won't. You would have to glue the port. You'd have to glue the whole thing together.
Well, you might be able to glue the port, right? Again, there may be ways that you could lock it down with super glue and make it compliant, but
it's they don't want it to be reach in with pair of tweezers, release the latch on the connector, and boom, remote ID is dead.
Right.
That's
the
what
same
the
with
FAA was
CAN.
trying to avoid. Yeah. So all the stuff's going to need some
Even if it's-
robustness.
Yeah, you
How
may
much does, like-
need. Sorry, go on.
Like a policy come into play? Or sorry, how much
So
do they
the-
care about like a
the
policy?
literal-
Like if we say, you know, it's in the case, and if you remove the case, the warranty is void. Does that matter?
When we ran that by the FAA, we did not get a warm read on that, and they did not.
Okay.
They did not make any official binding remarks about that. It just did not get a good read. The problem is that the requirement in Part 89 for tamper resistance is the device shall be tamper resistant. That's the entire requirement.
Right. They didn't define it.
No, exactly. And same thing with range. Range shall be maximized. What does that mean? So there's a lot of very loose, open-ended requirements in here. And the tamper resistance is one of them. You know, if it is got a harness, obviously there's some back and forth and two-way communication that you can use to verify the harness isn't compromised. But basically there's going to be quite a large wild card there for what the FAA ultimately decides, because not in a meeting that the ArduPilot dev team has had with the FAA, but in a separate meeting I was in, the FAA, one of the people from the FAA who was kind of one of their tamper resistance, specialists, was like, we'll know it when we see it. And that's literally what they told us.
What I expect is going to happen over the next few months is that custom carrier boards are going to come out for the ArduPilot, and those custom carrier boards would have remote ID built in. Hopefully using, a remote ID that's compatible with the ArduPilot remote ID firmware on the module, so ESP or NRF, and that will be how things are locked down. But of course, that's not there are no custom carrier boards that like that today. So you may need to go do the initial thing for September, using something that's not quite ideal, and then come back to it. And hopefully the FAA won't be so strict for the first month or two, but we'll see. It's all a bit uncertain on that side of it. But if there are any vendors on the call today that make carrier boards, maybe start thinking about creating a carrier board that has this built in. Because I think it's the big market.
Rich, we've got a thing on the drawing board at the moment that we're sort of waiting on all of this to become official before we can finish it. But it goes inside the Here 3 Plus. So the Here 3 Plus, obviously running AP per if, will have everything on board that is needed itself for every little bit of that. So it can be tamper proof and all of that sort of stuff as well.
Is that ESP32 based, or what's in the?
No, ESP32 is no good for USA, unfortunately, because of the whole.
How are you doing the Bluetooth then? Have you got Bluetooth built in?
Yeah, Bluetooth built into the system. So yeah,
you've done a Bluetooth add-on to an STM32, have you? Or
it's still under development, so we'll get to the details later.
Yeah, I'll separately chat to you about stuff and firmware development, because I'd like to help with that if you need it. Obviously, timelines are very compressed.
Yeah, I mean the biggest time limit here is just to announce something and then say it's going to be implemented in a month and expect FAA and FCC compliance. That's not going to happen for anyone. I mean, this is a pipe dream.
We've got to get it as fast as possible, though. Yeah.
Yeah, that's right. So anyway.
Rolling.
Sorry, were you saying that this ESP32 module actually can't be used for systems in the US?
It can be used in the US. It just can't be used for like a blue SUAS application. So if it's going to, however, I'm guessing that the blue SUAS will be exempt from this anyway, because I can't imagine many military people wanting to transmit their position.
Any military application is exempt from this. If the military is buying it, you're exempt. But if you're selling to like a police department, then the police department will have to have remote ID.
Yeah, we're in a major conflict there because DIU have not gotten the right to have an exemption yet.
Right. Okay. That gets exciting.
It's crazy.
All right. We might move on a little bit. So, on here, it talks about the various bits of hardware available right now. I suggest that people start prototyping right now using an ESP32 to get going. And even if you change to a different option later, at least you can start testing the ground station components, the communication components, get used to the whole compliance testing system just to get started. So connection options, currently we support Mavlink over UART or DroneCAN on CAN bus, 1 megabit CAN bus. Okay, moving on, ESP32 firmware. So ArduPilot has written a new firmware for the ESP32 S3 C3, only tested on S3 so far. As I said, we expect testing on C3 shortly. This firmware, that link there is the source code for the firmware, and there are also binary releases on that site for downloading and flashing yourself, and flashing instructions, so you can buy one of these dev modules and flash it yourself and end up with a working module the same as the one on my desk. It supports both Mavlink on UART and DroneCAN on the CAN port. The pinouts are in the README on the GitHub site, but if you need different pinouts, just let me know, trivial to change. I'm guessing that people will commonly do custom versions of this firmware with some of their own requirements, as they, for example, they might decide they only want to do Wi-Fi NAN or beacon, or only do Bluetooth 5, etc. Now, this firmware currently does not support, it supports Bluetooth 4, but not Bluetooth 5. We have to get Bluetooth 5 to be compliant with the means of compliance, the ASTM means of compliance. And that is something that I'm actively working on. I am hopeful that we will get Bluetooth 5 support in this open firmware in the next week or so, but we'll see. I've got to learn a bunch about Bluetooth. Buzz has already been doing some good investigations on that, and we're pretty hopeful we'll be able to get it going quickly. But that, just because of the range requirements and the way the wording of the means of compliance is for ASTM, we basically have to do Bluetooth 5 extended. All right, so the transmitter module basically listens for 5 messages on Mavlink or DroneCAN. And the way the DroneCAN messages are done is they are exact duplicates of the Mavlink Open Drone ID messages, field for field, one-to-one mapping. And that makes doing a dual protocol implementation trivial, because you're literally just copying fields from Mavlink to CAN. The 5 key messages are the basic ID, self-ID, operator ID, system, and location. The first 4 of these are supplied by the ground station. So let me just flick across to a implementation here. So this is MavProxy. So we have an Open Drone ID module for MavProxy, which is acting as a reference implementation. If you're using MavProxy in like Companion Computer or whatever, then of course you can use this implementation, but I would expect most people are going to be using the Mission Planner one that Michael is actively working on now. But as a quick test, you could use MavProxy. So basically, this is the data you need to set in the ground station. Let me just make that a little bit bigger and easier to read, hopefully. So basically, you have to give it and the meanings of all of these numbers are in the Mavlink XML. So you need to set your UAS ID type, your unmanned air vehicle type, your various area, the operating area, radius, floor, etc., all in meters. There's a couple of category numbers and classification types, description of the vehicle, operator description, I've just put in test pilot, operator ID type, location type, and how rapidly you're sending the data, which needs to be 1 Hertz or more, or faster. So that information, we're going to need a user interface in the ground station for entering this information. So that's where the Mission Planner plugin comes in to enter all of this information. Now, there's another key piece of information that is needed, which is the UAS ID, which has more requirements in terms of FAA compliance. There's information on Jeff's site about getting that. We're expecting very likely that vendors, at least in the early days, what they'll do is they'll bake that ID into the transmitter firmware. And the reason for that is the ASTM means of compliance document has a section on that number has to be access to authorized parties only using a process that is accepted by the FAA. Now, we don't really know what they mean by that, but our guess is that that probably precludes it just being a ground station entered thing. Probably what we're going to do is have a means of baking this ID into the transmitter firmware, which you ship with the vehicle. And then, so you'll end up with a custom firmware per vendor. And with that ID baked in, you'll need to get that ID allocated. And Jeff has information. He's got a really good page on his website. If you look up here on Jeff's, where's the Jeff's page on this?
It's towards the back.
Towards the back. Okay, there is, yes, here it is here. This page you will need to go to. You can do it yourself, but I would highly suggest you just, pay Jeff and get him to do it for you, because it's going to save time, and time is of the essence. So this is information on that ID, and then we're going to have a process of baking the resulting ID into the transmitter module firmware for you to ship. And because otherwise we're going to fall afoul of this access to authorized parties section. So any questions on that side of it at all?
They said what the fines are for non-compliance?
No idea. That's not my department. Luckily, I'm in Australia, so hopefully I'm not going to be fined.
It'll be at minimum an arm, a leg, a firstborn, and a lifetime of being on a list you don't want to be on. But they've not specified a fine.
So you can see here, so once you've loaded the firmware, the ArduPilot firmware, you will find that there's DID parameters, which is the drone ID parameters. And now, I'll just go back to the presentation because I've jumped slightly out of order here. So let me just wander back here and keep presenting for a second. Now, this is not allowing me to present. So let me see if I can get this thing to allow me to present again, so I can actually do the slideshow again. There it is. Okay, and back. All right, so jumping in here, so we've done it's an ESP firmware. It has these various messages here. Then there's a message that comes back from the transmitter module, which is arm status. And that's your go, no go, because the requirement from the means of compliance is that you cannot arm and fly the vehicle unless that transmitter module says you're good to go. So that is the key message. Very simple message. It's just an integer go, no go, and a reason, a string that explains, which is only filled in if it's no go, if it says you can't arm. And it gives you the reason why you can't arm, and then you have to fix it. So, for example, if it doesn't have the operator location, doesn't have the various IDs, the transmitter module will say no go. There also needs to be either an audible or visual indication, which means either an LED or a buzzer or a speaker or something. So I haven't added it yet, but I'm planning on adding the pinouts for an LED on the module so that you can get a nice bright LED on your vehicle that gives you a green, go. When you're allowed to arm, and that is a requirement that you have a visual or audible indication. All right, I've already talked about the drone CAN messages. They're already merged into drone CAN DSDL. The ArduPilot firmware. So ArduPilot.
Question, Andrew. If you could go back to the previous slide.
Sure.
So I've looked at the ESP32 datasheet itself and says that it is a Bluetooth 5 solution. And earlier ASTM standards say you could either implement this in Bluetooth 4, Bluetooth 4 and 5, and network remote ID. Does the current firmware, what are the solutions that are implemented in the current firmware? Is it one of those options, all three?
There's a point to be made here to clarify things. The FAA has made it clear that even though F3411 supports Bluetooth 4, the Part 89 requirement is Bluetooth 5 and 4, because you need both of them.
Yeah.
Or you do your Wi-Fi based solution.
Right. So the current module, the firmware that's running on my desk right now is, did somebody just draw on my screen?
Oh, I'm sorry. I don't know how to, one moment.
Unfortunately, that there's a bug in Linux. If you draw on my screen, I've got to reboot. I know it's crazy. Or somebody can kick me out of the call. Can somebody, I literally can't do anything. I can't type, I can't see the screen, it's all black. So can somebody please kick me out of the call so that might restore my screen so I can, or stop me screen sharing. I've given people.
I can do that.
Randy or Craig, you should have access to kick me out. There you go, back. Thank you. Okay, yeah, nobody draw on my screen. There's a bug in Linux. If you draw on my screen, I literally can't type until I either reboot or somebody kicks me out. So I'll start screen sharing again. Great. Okay, it's a horrible bug. Zoom is, yeah.
Andrew,
Right. Yep.
Andrew, quick question. So the transmitter module sends an arming okay, not okay system. What?
Yep.
Is there a way to bypass that? Say you're operating the system indoors.
Okay, there is a rather tenuous paragraph in the means of compliance document that talks about indoors and urban canyons. And it basically, and the wording, let me just bring up the wording because it's rather important for this use case. So if you bring up this, so there is this paragraph here. Note 6, as stated in note 3, the pre-flight self-test, right? That's the part that gives you the go, no go, does not require establishing a location fix or specific accuracy to pass. Under certain conditions, indoors or GNS canyon, this may not be possible. So that gives you an out, and then you need to then read down to note 3. Although the aircraft must be designed to meet certain accuracy requirements, the PFST of the specific hardware science does not require establishing a location fix or accuracy. So exactly what this means for indoors and canyon, I think we've yet to really establish that. I think if you're planning on selling a vehicle that can be operated indoors or in urban canyons where GPS is going to be compromised, I think you should have a detailed read of this document and a discussion with Jeff about how you might comply. It looks like there may be a path forward, but I don't properly understand it given all the other pieces about accuracy that seem to conflict with this note. So it's a definite maybe. Does that answer the question for the moment?
It sure does. Thank you.
All right. So you need to go and buy yourself the means of compliance document sort of straight away. Okay. So moving on for the ArduPilot firmware. So the ArduPilot firmware support is merged into master as of yesterday, and many thanks to all the people doing reviews and working on that over the last week or two. It's been great. Support is also in the 4.2.3 beta 2 for plane that I released this morning. That's the major feature in the beta 2 is Open Drone ID support. And as I've mentioned before, we expect a copter beta and then stable of beta and copter and plane probably within the next 2 weeks. And I'm going to be working on a backport to at least 4.1 in the next few days. If you need other branches, contact me. Or contact me on your partner support channel would be better actually, so other people can get involved rather than me just personally. The key parameters you need to set in ArduPilot: DID enable to enable the drone ID system, the CAN driver to say which of the 2 CAN drivers. So, you know, you can have 2 CAN drivers on the 1 port or sorry, on 2 ports or on 1 port, etc. We've got this concept of a CAN driver. In ArduPilot, that's how you link to it. You've got a Mavlink port, which Mavlink port to use. I would say if you're using CAN, you still want to set the Mav port. I'd suggest setting it to 0 for USB for testing. That's what I've done in my Mav proxy, and that allows me to get all the nice little Mavlink drone ID messages showing up on the ground station, coming back to the ground station, or going to say serial 1, even though using CAN, very useful for debugging purposes. DID options, the most important is bit 1 of DID options. That's what enforces the arming checks. Means you cannot even do a forced arm without it passing. Now, obviously, the tamper requirement is in the, if you look at the means of compliance, the tamper requirement requires that there's no user-facing interface way of turning this stuff off. That means the ground station cannot turn off all of these things. Right? Plus a whole lot of other things. The ground station cannot, for example, go and change the GPS type to being some external GPS or source of position. It can't change the AHRS EKF type to, for example, an external AHRS or an optical flow or whatever, because otherwise you're no longer going to be compliant. The mechanism we're using for that is a lockdown mechanism via the default stop PALM file for your particular board and the read-only tag. So what that means is that a vendor who wants to comply with the FAA's remote ID requirement with ArduPilot is going to have a custom firmware. You cannot use the click-in mission planner install standard CubeOrange firmware. That will not be compliant. Instead, what I've done, and I'll just stop sharing for a second and I'll show it in my editor. Sorry about this. So APM, look inside the plane 4.2 HWDEF, and I've done a couple of examples. I've done examples for Pixhawk 6 and CubeOrange. This is an example for CubeOrange that I'm running on my desk. It's very simple. In the hwdef.dat, you need to give a new board ID. You cannot use the same. Oh, yep.
Sorry,
my
are you sharing your screen?
My apologies. I've lost the screen share. Share again. Okay. Can you see now? All right. My apologies. So what I've got is in here in the libraries APL Shibios HWDEF, I've created a CubeOrange OD ID, and that is built into the Plane 4.2 release and master. That is a custom build of ArduPilot for CubeOrange with Open Drone ID support. There's 3 parts to that. The first part is it does an include of CubeOrange HWDEF.dat. So say, it just inherits from CubeOrange. Then what it does is it sets a different APJ board ID. You have to change the board ID and change the bootloader. The reason for that is to be compliant, we cannot allow the end user to click the button for update firmware in Mission Planner and say update to standard CubeOrange firmware without Open Drone ID and go fly. That wouldn't meet the means of compliance. So we can use the, yep.
The stuff that Sid's doing for India at the moment,
that's relevant.
That would also be a legitimate use, wouldn't method?
Oh yes, yes. That's with signing. Indian requirements are much stricter, and so that has bootloader signing of firmware, etc. We may well need to go to that step for the FAA, just depending what the FAA say. Yep. I know. This is much less strict.
We already have that capability in Mission Planner and obviously for CubeOrange. And we'll be making that a lot easier through drone share in the future. So
indeed. And that's a very viable solution and potentially a very good one. What I'm presenting here is easier than that. It doesn't involve public key crypto, etc. And signings. It's easier for people to roll their own. But you're absolutely right. It could be we have to go to what you're talking about with the bootloader signing for the FAA, depending on how they react to the declaration of compliance once we put this together, right? But I believe this meets the ASTM means of compliance, because the means of compliance, I'll just show you the wording on tamper resistance. So tamper requirement.
Someone's unmuted as well.
Yes.
Background check.
If maybe, Craig, could you look at who's talking and silence them? Or Randy? Thanks. Okay, so tamper requirement for standard remote ID, which is what you need. So there's 2 types of remote ID, standard and broadcast. If you're selling a vehicle, you need to meet the what's called standard requirement. The unmanned aircraft must be designed and produced in a way that reduces the ability of a person to tamper with remote identification functionality, right? And the next part of it that matters is there's a section on the user interface. So basically there can't be a user-facing parameter for turning this off, right? So part of that is the board ID, so that ArduPilot's bootloader refuses to load the firmware without the Open Drone ID support. And I'm going to be adding into our bootloader the same support we've already got in AP-Perif for bootloader checking the board ID before allowing it to boot. And that will strengthen this quite a bit. So basically what I've been doing is adding 10,000 to the existing board ID. So if you look at the list of board IDs, so if I go back to tools, AP, bootloader, board types, this is the board IDs of all of the different types that are, ArduPilot supports, and there's rather a lot of boards we support now. I've added a new section at the bottom, which is 10,000 plus the original board ID, and I've got 2 of them done so far, Cube Orange and Pixhawk 6. And I would encourage you for your own boards, we can just add these in, and that then gives us a board ID. So that's the first part. Okay, allocating a board ID. You have to do that both for the main firmware and for the bootloader. You have to rebuild the bootloader, then you have to flash a new bootloader to your board so that users cannot just use the standard firmware. Then what you need is a default stop palm. This is the defaults that get baked into your firmware. The key part is these Open Drone ID defaults, right? And notice that we have marked a number of key parameters as read-only. Now, this list of read-only parameters is likely to grow before the September the 16th deadline, but these are the basic ones. So this enforces that DID enable is on, the arming check required, arming check is on. I've set this up for CAN, so mavport is -1. You may like to set that to something else if you want UART mavlink. I've set it up to use the first CAN driver, and I've forced EK3, so you can't bypass by using a different EKF type and injecting positions via the ground station. I've also marked it as GPS type 1. That should actually be marked as read-only, and GPS type 2, because you're not allowed to go and plug in a fake GPS or whatever. You've got to enforce that. So we will need a whole set of parameters. This list is likely to grow to be 30, 40, 50 parameters long that have to be locked down, so that you can't just use Mission Planner's parameter interface and turn off Open Drone ID via some sneaky parameter.
Oh, Tridge, the GPS type of 1, does that work with
Oh,
CAN?
it'll probably, no, this is per vendor, right? Each vendor has to do this individually, and they will have to craft this to match their vehicle. So that will likely be 9 for CAN. It'll likely be 2 for U-blocks.
For the case of Cube Orange, though, it's semi-generic, right?
Well, this is a template example. Every vendor is going to have to do them themselves. Now, I'm happy to help them. So if a partner comes to me and says, I need a custom firmware, which is using the following configuration, I need CAN GPS on first GPS, U-blocks on second, or, whatever, I can then trivially craft this for them, build a firmware, there you go. But yes, every vendor is going to need to do this, because, the age for people in the US shipping commercial products, the age of just using the generic firmware for our build server is over. You are going to need to start supplying custom firmware. So I just gave this example as a way to get started. And we're here to help you ease that process. But it's not just going to be a matter of downloading a generic firmware, because you cannot be compliant if you do that. All right. Any questions on that at all?
One more quick question.
I have a question there.
Yep, go on.
I'm sorry, someone spoke up before I did.
Sorry, I'll go really quickly. So so we use a custom ground control station. If that GCS does not allow changing parameters, do we still have to abide by this? If our customers don't have Mission Planner installed.
I don't know. You will need to read the means of compliance document and see if you think it complies, and then you'll have to do a declaration of compliance, and then you'll have to convince the FAA that that's correct. Personally, I think you should do this anyway, because I think there's a good chance you'll end up getting rejected, and then that'll just waste time.
Yeah, that's very likely. What Tridge is saying is very likely to be the outcome. You will probably have to lock the thing down, because it's one of those things where one of the things the FAA explained to us was that they don't want it to be some very simple, internet article that your average 7th grader can follow and bypass these measures. They want it to be substantially more complex than that. If you have to get out a JTAG cable, that's one thing, but if it's 7th grader free software and done, then that's not going to meet their expectations.
Right. Is there any exemption for R&D or anything like that? Test flights?
There was, we asked about this, and if you're in a net, the net is considered indoors. So if you set up an outdoor test area that has a net, now for the aircraft like you guys have, Tom, that's not going to work. You'd probably have to go to a FRIA, which is one of their authorized, tests, or not tests, but flying fields, or you would have to have some sort of remote ID device on the airframe in the form of like a module.
Right. So anyone that's, yes. So even for development purposes, if you're outside, you are therefore covered. Now, how does this work? I'm sorry, you're not covered. You must be compliant, I guess. Yep. How does it work where your aircraft is not designed to be under the jurisdiction of this altitude? And for example, our aircraft is a high altitude aircraft, and they're usually using an ADS-B out. Does that make us that we need to use both, or are we just totally exempt and don't need to broadcast whatsoever?
You need to get a letter from the FAA for that one. Okay. Or you need to talk to the FAA directly. That's beyond the scope of what I've researched for this. I have some feelings and some suspicions about where that's going to go, but the ultimate answer is the FAA has the jurisdiction, and so you'll need to get them to cough up an answer on letterhead for you.
The way the standard's written, it looks like 100,000 feet is the ceiling for locations that you have to provide. So if you're above 100,000 feet, your spacecraft sort of thing, you might be able to get away with it. But it's I think it's 30 something thousand meters.
Hold on, so it actually does specify an altitude, that if you're under the altitude,
there is, well, no, what it says is it talks about,
it runs out of bits, I think.
Yeah, it runs out of bits. It just, you cannot represent. So above that, you just say invalid altitude.
Okay, well, it's higher than ADS-B.
Yeah, but it's around 1,000 feet.
Is there anything regarding private ranges? So not military ranges being on a MOA.
FRIAs.
That would be a FRIA. If it's a FRIA, you can fly within the scope of the FRIA. But if it's not a FRIA, like let's say it's a private property, like a cornfield that you're flying over, for example, that your friend owns, you would still be subject to remote ID because that cornfield is still under FAA jurisdiction.
Yeah, so a FRIA is like the, I think the AMA, the Air Modeling Association, I think I've got that right, in the US. I think they've got FRIAs at a bunch of their fields, so people will be able to fly their model aircraft.
You pretty much have to be an AMA sanctioned field to be a FRIA, is the way that the rule was written for that.
Yeah. But that's not going to apply for most vendors.
Fred, I have a question about the board ID scheme.
Mm-hmm.
So it seems to be, it obviously it makes it so that you can't just download the firmware from Q ground control or whatever.
Yep.
But it's a sufficiently motivated user could build a custom firmware with a matching board ID, right?
Indeed, that's right. And we are hoping that is outside the scope of the, reduced tamper thing, because, sufficiently motivated user will just remove the cube and put their own cube in, right? And so, at some point there's some level, but we could go to signing, we could go to public key crypto, we could have a private key baked into the ESP32 transmitter module, and then we could have a public key, and you have to encrypt and check the firmware. All of that stuff's doable. We're hoping we just don't need to, and our current reading of it is we expect that what I'm presenting today will be enough. It would not be massively surprising, though, to find that the FAA says, sorry, it's not enough, and we have to go back and start doing the whole public key thing, in which case, working with Sid on the stuff he's done for India is likely the fastest way forward.
We had Alex
if they end up saying it's not allowed, then don't we get into a conflict with GPL? I mean, they're telling us to TiVoize the device, right?
Well, okay. So for start, the GPL actually doesn't apply because this is not a consumer. This is not something you're flying in your lounge room. It's not a DVR like the TiVo was. And the GPL v3, that clause that you're referring to as far as scripts, keys, etc., only applies to consumer devices. I was part of the committee that created that that section of the GPL. And my interpretation of it, and I think everyone else's interpretation, is that, you know, the sorts of UAVs we're talking about on this call, commercial UAVs, are not the sort of things you fly in your lounge room. Something like the Sky Viper may well be in trouble with this, because that's a toy that's designed for indoor use, you know, by kids, and they may well need to come up with a different means of compliance. We haven't even tried to scope that out yet.
Yeah. Let me inject here a couple of things on this. So the verbology on there is in-house personal use. So for the sake of a commercial drone, typically like an employee would be using it, so that it's void anyways, just for that matter.
Exactly. Yep.
But
that's right.
In-house is actually a very specific thing. It's designed for off-the-shelf sort of devices for personal use.
And, so and it's what it's designed for. It's the intended use of the vehicle, not the actual use. So somebody can still fly it personally, right? But when you're producing the vehicle and you're meeting that GPL requirement, it's what the intended use is of the vehicle. And if this is intended to be sold as a commercial vehicle, you know, doing photogrammetry in the US or whatever, that's not, you know, a personal use in your lounge room. So that clause in the GPL does not apply.
Yeah, and that basically is sort of a, I don't say catch-all, but it avoids a lot of the worries about GPL anyways. So a lot of the concerns people have with GPL v3 kind of get thrown out the window just from that clause in the drone world, because it's like, it's not an in-home thing, especially if you're a commercial thing. For all arguments against that basically are avoided. And
for the record, I was actually on the camp that opposed putting that catch-all, you know, exemption in when the GPL v3 was created, but I'm glad now that they did that. So, all right. So
actually, I want to speak a little more about that. To be, for example, there's actually medical devices that use GPL v3, but you're not allowed to tamper with them.
Exactly. And that was one of the things that was brought up in the committee. Medical devices were one of the main reasons. That's why they made it consumer devices. So really, they were targeting TiVo-like devices. All right, so so lockdown is a thing, and you'll need to start getting familiar with, you know, creating custom firmwares. Of course, the partner support team is here to help you. It's actually a fairly trivial process, and so, you know, ask us if you need help for your firmware. Board IDs, parameter locks, so this I've already discussed this. So we're basically doing this 10,000 plus board ID, each person creating their own custom firmware, or each vendor. Ground station support. So the ground station is provide key data to the flight controller. That includes UAS ID, operator ID and description, operator area limits, and various classification IDs. They're the ones I showed you in that MAV proxy Open Drone ID module just a few minutes ago. And they're all provided using the Open Drone ID messages. There is a sample implementation in MAV proxy at that link. And so if you're building your own implementation, if you've got your own ground station, then go and have a look at the MAV proxy one. It's actually very simple. Main thing is the user interface component. You've got to have some way of setting these various key numbers and IDs and who's flying the vehicle, etc. Michael O'Bourne is actively working on this, and in fact, he's already implemented a fair chunk of it as of yesterday. So I downloaded the latest beta of this morning, and it's already got a bunch of the support in it. We're also going to need a Q ground control support, I believe, although I imagine some people might run both QGC and Mission Planner parallel on their phones or Android tablets for initial support before we get it into QGC. This is the nascent Mission Planner support. So you can see as of this morning, Mission Planner, this is the CAN inspector. You can see the Mission Planner ArduPilot remote ID module sitting there on the CAN bus, and alongside a Cube Orange and Mission Planner itself. This is just using MavCAN to talk to a Cube Orange. This here is the inspector showing the various packets, basic ID, location, operator self, etc. All of that stuff being transmitted over the CAN bus. And then the all-important arming status message, which is giving status 0. That status 0 means we're good to fly, good to arm. And so that's the packet that is the key thing to get you off the ground. Any questions about that at this stage? All right. Vehicle serial number.
Sorry, Trish, we've got a little question there from Tim in the chat.
Yep.
If one uses UART, maybe you can read the chat yourself.
Yes. So Tim, he says that if one uses UART and one uses CAN, are there different packages, different GPS installed with each variation need a different board ID? So you could enable both serial and CAN in parallel in your firmware, which means people could plug in on either. But the key thing is can you plug in at all? Or are you going to have to actually have like custom carriers? The cabling side of this, I'm just dealing with the software. You have to also think about the cabling and how exposed that cabling is to an end user unplugging something and plugging in a different module and bypassing. So that's the tricky part in the answer to your question. Firmware-wise, you can create an ArduPilot firmware that does CAN and serial in parallel, and which means the one firmware will work for both. But hardware-wise, how you achieve that is more in Jeff's, area than mine.
We'll take the example, the other example I gave with the different GPS. My understanding from what you said is you have to define a package of what this device includes. So if it includes a specific GPS, there's a parameter for that. And
well,
you have to lock it down.
Okay.
So if you have a different GPS, would you not have to have a different board ID for that?
It depends. If it's a U-Blocks, then you just set it as U-Blocks and you're done. It'll support all the U-Blocks modules, right? If, however, you want to do a Septutrino, then yes, you will need a different GPS type. So if you're planning on shipping your vehicle with multiple GPS options and they're not compatible as far as the GPS type is concerned, so for example, you're offering customers either Septutrino GPSs on UART or serial U-Blocks on UART, yes, you would have to have two firmwares to support that. If, however, they're both DroneCAN compatible GPSs, so they're both using APPREF, for example, that's just the one parameter. You set it to GPS type to DroneCAN and you're done. Now, there are changes that are needed. There's an APPREF update, which we completed yesterday, and we expect to do new APPREF firmware releases in the next few days because we need to do WGS 84 altitude. And up till now, APPREF-based GPSs were only doing AMSL altitude, whereas the standard mandates WGS 84 ellipsoid. So there's going to be a new APPREF firmware release for APPREF-based GPSs to support that. So look for that update if you're using an APPREF-based device. My understanding is that the HERE 3 already supports the AMSL, and so there's no need to update the HERE 3 CAN device. Sid clarified that yesterday because they've already got the WGS 84 altitude in the protocol, is my understanding. Any more questions about that? And Tim, is that a clear enough answer?
Yeah, I think that's pretty clear. Thank you.
Okay, great. So vehicle serial number, as I mentioned earlier in the call, vehicles need to have an assigned serial number. Serial numbers have to be in accordance with this ANSI CTA 2063, which I have not read, but Jeff knows all about. Fastest way to do that is to go to Jeff's website here and get him to get you one. But you can, of course, do it yourself. But you're going to need that ID because that has to be broadcast. And we're going to be adding a mechanism of baking that into the firmware. Exactly how that'll work, we haven't worked out yet, but you can start testing now with the existing one and just put in a 1, 2, 3, 4, 5, 6 as the ID. And then we will shortly be updating this to tell people how to get these numbers into their transmitter module firmware. Any questions about that before we move on?
The serial number needs to come from the transmitter. It can't come from the cube. So I'm assuming this is not
it comes from the
serial number.
It comes from the cube. So that's the airframe serial number, or it's a ICAO some sort of ICAO identifier. So like if the FAA decides we're going to start assigning session IDs and a network remote ID down the road, then you'd get the session ID assigned.
Yeah, one of the methods. Yeah, sorry, go on.
But yeah, so and getting the serial number put together, that's like, it's not superly duper hard. If you haven't done a serialization scheme before, then most of the work there is just setting up a scheme and then doing all the record keeping that goes with serializing the product.
it needs to be baked in. It's probably won't be compliant with being a ground station thing that you enter. So we will probably support something like this. We don't support it yet, but being able to put this in the hwdef.dat for building it into your firmware, but we'll also probably support it baked into the transmitter module. I'll just close that so we don't get pop-ups from there. So we'll probably add support for something like this shortly, but we're still working out the details of exactly how this is going to be piped through.
So sorry, Drew, just to clarify there, so you're saying that it could be in that, sorry, the vehicle ID could be in either the transmitter or in the ArduPilot.
hwdef.dat. Yeah, that's right, because it can be transmitted from the ArduPilot over DroneCAN or Mavlink across to the transmitter module, or we could bake it into the transmitter module. We'll probably offer both options. The easiest will probably be to do it in the hwdef.dat. But we haven't yet implemented that mechanism to do that. I'm planning on doing something like this and then having a patch to the AP Open Drone ID firmware that supports this. But that hasn't been done as yet. So,
and I guess from a vendor point of view, it might be more convenient. I mean, I'm not a vendor, so I don't exactly know, but having to build a different ArduPilot firmware for every single vehicle.
Yeah, exactly. And that's partly what
than having a transmitter specific firmware.
That's right. That's partly why I'm thinking it's going to be a lot easier in the transmitter module, because basically you bake it. There'll be some process of basically substituting the ID in the transmitter module firmware. You flash that once and you ship that transmitter module, and then all your customers run the one firmware. Otherwise, each customer will need to bake the firmware, which is going to be painful. So although we could use like an APHA tool method of updating it so you could custom firmware, but providing individual customer firmwares could be really painful. So personally, I think the most likely solution
that's something we can help with.
Yeah. So this part is, as you may have noticed, something that is still a bit in flux, but very likely we'll end up with multiple mechanisms of getting this vehicle ID in there. And watch this space for the detail.
So to clarify, that ID has to match an ID on the transmitter, or it's just
that ID has to be broadcast by the transmitter module, and that ID has to meet the requirements in ANSI CTA and come from this process of serial number assignment that Jeff can do. So,
but you're defining it in the HWDEF. So is the idea
look,
that
one option will be
ID and then
it's defining the HWDEF, but I expect the most common mechanism will be to bake it into the firmware for this device, right? Your transmitter module. Okay. So that when you ship the transmitter module, it will have an ID baked into it. So you'll have to go through a process for each customer of pressing a button to generate custom firmware with the ID for this vehicle, press the button to flash using the ESP flash tool, stick it into the vehicle and ship it like that. And then it's got it baked into it, the ID for that vehicle. That's what I'm expecting is the most likely process, but we've yet to implement that process. So it's all a bit vague at this stage. Does that make sense?
If there's multiple flight controllers, would you need to differentiate between each flight controller, or could you say
it's a vehicle ID?
Okay.
So if you've got multiple redundant flight controllers in your vehicle, then I'd say use CAN, because that way the CAN bus is common, hopefully between them, and they can all get that arming status, etc. B, it should be that this ID is just a vehicle ID, which is on the transmitter module and is common. In fact, the flight controller doesn't even need to know this ID, because the transmitter module would be broadcasting it directly.
Yep, thanks.
All right. So certification and testing, and this is a big one. I might hand over to you, Jeff, for discussion of this.
Okay. So one of the big significant things the FAA put down in Part 89 is that you need to have your FCC paperwork done, which means you need to have EMC testing, and you also need to have any transmitter testing done. So if you've got devices with modular transmitter certifications and they're not co-located, you can inherit those and then use EMC testing only. But if you don't have a situation where you can avoid co-located transmitters, or you don't have modular certification on your transmitter, then you can run into some issues. So this is a huge, probably the largest stopping block for pretty much everyone here, is the FCC, EMC, and transmitter testing requirement. You know, in my experience, having done many products through this procedure, this is like a 10+ week thing if you haven't already done it or haven't started it or whatever. So this is the biggest probably hurdle here. Then the results of your MOC testing plus your FCC paperwork, that all feeds together to make the FAA DOC. And then we're going to be using, which is what we've been basing all this on, is this F3586 MOC document, which the FAA accepted on Friday, and they are still yet to publish the official acceptance in the Federal Register, which is the US, official, it exists to the government if it's been published here. So those are kind of the big elements there. Going back to the FCC to address Connor's question, co-located transmitter is any transmitter where the antennas are less than 20 centimeters apart. So if you have two antennas that are less than 20 centimeters apart, you will have a co-located transmitter situation. Unfortunately, with the way a lot of the drone products work, you are forced into a co-located transmitter situation. And also quite a number of products that I've looked at do not have a modular certification, and you're looking for a full modular certification, not a limited modular certification. And that is indicated in the FCC documents for the product. So you look up the FCC ID on either the FCC's website or on like fcc.io. Which is a private service that scrapes the FCC databases. You can look at the test report documents and you can see if it's and the transmitter grant, and you can see if it's a, whatchamacallit, full modular or if it's a limited modular. There's another thing to note here in nomenclature. FAA's definition of modular and the FCC's definition of modular are not the same. And that is a huge source of communication error in discussions here. The FCC definition of modular certification is like the little ESP32 modules that you buy that have a little RF can and an FCC ID. That's a module. To the FAA, a modular remote ID transmitter or modular remote ID device is like a little puck that's almost completely self-contained. It has a different regulatory scope under Part 89 from standard remote ID.
So I'd just like to point out that this means of compliance document, right, which all of you should go and buy, has a whole big slab on testing methodologies. So exactly, distances, pass criteria, steps, how you do the flight tests, what equipment you're going to need. So basically, this is a step-by-step guide and a checklist for passing. So basically, every vendor is going to need to get to know and love this document and go through all of these steps in order to be able to get a declaration of compliance. So get this document now, start getting your people lined up to start doing this type of testing, probably initially with like an ESP32 dev module to prototype it, even before you have all the hardware lined up for exactly what you're going to put in the vehicle, just so you're all set up to run through this as fast as it's possible, so you're not blocked from selling things as of September the 16th.
And also another thing to note in here, we intentionally framed 3586's test procedures to use as few specialized high-end RF tools and other, fancy trinkets for testing as we could. However, the FCC testing does require buckets of paperwork, buckets of test equipment, and that's going to be probably the single most expensive line item in getting this done. And it will be the single most expensive line item probably by a substantial fraction.
Yep. All right. Any questions, sorry, on certification and testing before we move on? Okay, discussion. So obviously, the partners call is a great space to discuss. We have a partner regulatory channel on our Discord server that is partners only channel for discussing all regulatory things. And I think remote ID is top of the list right now in that. Yesterday, I created a public open drone ID channel because we want to welcome people that aren't partners to come in and be part of this discussion. So you can also, follow along on that channel and just be aware that that is a public channel. So anything you talk about there will be available to anyone who cares to look. There's also the partners mailing list where you can discuss things and hopefully get together with other partners to get solutions together. And of course, there's the partner private channels. As I said, I would encourage you where possible to use means of communication that involve, all of the partners, just because we're all in this together, and it'll lessen the load on the partner support people if we're not, trying to help each one individually. We obviously will, if we need to, we'll help as much as we can, but there's only so many hours in the day and there's a lot of partners. So try to ask on the general partner channels if at all possible. All right, so that is the end of this slide deck. So anyone who doesn't sell products in the US is probably feeling very relieved right now. For those who are, you're in for an interesting ride over the next month and a bit. Any other questions or anything before we very, very briefly go through our standard monthly partners call?
I do have a question. And this may not have an answer, but if you sell a product in the United States that is only used in a FRIA or it is only used indoors, then is that still allowed? Or is the FAA going to come in and say, well, it could fly outside, so you have to comply? Or is it enough that the customer promises never to fly outside?
That's an FAA question. That's a regulatory determination that we can't make here.
You'll have to ask them how quickly that answers.
So how does one ask them?
Ben Walsh at the FAA is probably the person I would ask, and he will either have the answer or know the person who can get the answer, or will organize an answer for you. And he's been super helpful on the ASTM side. He was sort of the FAA's day-to-day representative for anything policy related to the ASTM work group. When we had a policy question, it was usually his task to go and either get an answer, and whether that answer was useful or an I don't know would depend. And it's Ben Walsh, and James just posted his email in the chat. And like I said, Ben is a really cool guy. He's been extremely helpful. So, he's probably going to be feeling the pressure just like everyone else here. And, he certainly will do his best to get your questions resolved, or at least to a disposition where the FAA has, given you their official stance.
Okay, thanks.
Just one more question on my side. I joined the call late, so just if I've understood correctly, now from 16th September, we have to comply with the new FFA and FCC regulator to even think about basically sending it to US. Is that correct?
Yes, that's correct.
Yeah, not having the functionality, but we have to comply and give the documents to FAA to get it approved, and then only you can send it.
Yes. Now this call has been recorded, so you'll be able to watch the video on we'll put the link on the partners channel if you arrived late, and to go through the earlier discussion, because there's a lot of detail we went through. The slides are also going to be, I'm planning to publish the slides that you've just seen on all sorts of places, Facebook, LinkedIn, etc. shortly, probably Twitter as well. So there's a fair bit of information there, but there's an awful lot of detail from the questions we had today that you might like to watch the video. But yes, if you're going to be selling in the US, you need to start thinking about this.
Yep, thank you.
George, will you be sending a link to the video of this presentation?
Yes, I'll send it to the partners channel, partners email mailing list. It'll also, normally I put it up on the partners channel on Discord, but I think I'll also send that out to the partners email list, the recording of this video. That should be, an hour or two. It takes a while to transcribe the video on my computer. So be a couple of hours before the video is up.
Okay, great. Thank you.
Please don't share the video publicly. We like to keep partner calls within the partners program, but the slide deck from the link to the slide deck can be shared publicly. So, oh, by the way, if anyone has a Bluetooth 5 implementation already done then please let me know and see if you can share it. We need Bluetooth 5 support. I'm hoping to get it done by next week, but you'll save me a couple of days development effort if you've already got one and you're willing to share it. And I'd greatly appreciate that. But otherwise, I will be working on that this week and hopefully get it out for next week.
We'll send hardware as soon as we've got it.
Excellent. Thank you very much, Philip. Okay, so I think we might switch over to our regular partners call, but we'll keep it brief. So if people were only here for the remote ID, feel free to head off. Otherwise, I'll share my screen and do the regular partners call. But as I said, we'll make it very fast because we're all exhausted from that. Can you see my screen now with the normal August development report?
Yep.
Okay, so this is going to be the accelerated version of this one. So summary, lots of code went in the last month. Lots of driver changes. One really notable one is we've now got support for when you fetch the parameters via FTP or in logs, we have the default parameter value as well as the current parameter value for every parameter, which means in Mission Planner and Map Proxy now, you can actually say, only show me parameters that aren't the default and show me the true default value. So that's built into the protocol as of 4.3. That'll be for 4.3. Now, timeline-wise, I should mention, by the way, we are planning to start the beta for 4.3 this month. So likely in 2 or 3 weeks' time, because that's our timeline for 6-monthly releases. So there will be a 4.3 coming your way soon. Various other things here, highlights, there's new IMU, there's all the usual sort of updates, and there's one big one, the OpenDry Node support is in the changes from the last month. Randy, over to you for Copter update.
All right, I'll be brief. So 4.2.2 went out. It's just got a couple of fixes in there that are listed. If you're a Trad Heli user using AutoTune, you should definitely upgrade to 4.2.2. Otherwise, just update when it's convenient for you. As Tridge mentioned, 4.2.3 should start beta testing quite soon. So maybe by the end of this week, maybe very early next week, we'll push that out for beta testing, and that'll include all the remote ID goodness that we talked about earlier. And of course, we are working on 4.3, and just like for Plane, we'll start beta testing that probably around the end of August, maybe the very beginning of September. All kinds of great stuff in that as well. Some of the things that are actively being worked on. Leonard has done some payload place bug fixes, and Andy Piper and Leonard are also working on anti-gravity support, which sounds super cool. It actually means, it's a control improvement when the vehicle has very high throttle. Sometimes you may notice if you have a vehicle moving very quickly at a very high throttle, it may bob a little bit. So this tries to resolve that. Maybe that's it for Copter. Oh, just one little thing. There's a link over on the right side there. There's a company called Skybrush, which uses ArduPilot for drone shows. It's a fork of ArduPilot, but there's a blog post on ardupilot.org showing their GUI and how you can use it in case you want to do a drone show. That's it.
It's incredible what they've done with Skybrush. Really, really great drone light show software. All right, Plane update. Plane stable is currently 4.2.2. 4.2.3 beta 2 went out this morning. It's currently being built on the build servers. Whole bunch, there's Pixhawk 6X support and 6C, various fixes. The key thing was, from the quad plane point of view, we fixed an overshoot problem in VTOL landings, which could be quite nasty, could cause a vehicle to fly quite a long way past the landing point and then slowly make its way back. It's now a lot better for when you get that overshoot. And of course, the big one is the Open Drone ID support, which is in the beta 2. And I'm expecting that the final of 4.2.3 will be out within the week. Already had the discussion on Open Drone ID, so we'll skip past that. So GSOC update. So GSOC is off and running. I'm working with Emre on the custom controller using Simulink. Really nice work he's doing. Randy, do you want to talk about the couple of GSOC projects you're involved with?
Sure, yeah. So we're about halfway through now, I think, the GSOC development period. And just on the right there is a picture of the autonomous docking. It can be used for boats or rovers. So for example, if you want to get the boat or the rover into a charging station, or if it's a boat you just wanted to get onto the dock, so you can tie it up. We've got a new flight mode called dock, which will autonomously do that. It requires like some kind of tag be on the dock, maybe like an April tag or something like that. But yeah, progress is coming along well.
All right. Okay, so that is the end of the partners calls. We as it's very compressed. We normally go for about an hour or so just on the partners on the normal monthly call, but I know you're all tired. So Philip, do you have a question?
Just on that latest update, I think that also had Orange Plus in that last release that you did.
Let me see. I don't remember it. I could, if it's not in there, can maybe Sid could go and check that we have got that in there, because if it's not, then I could sneak it into the final of 4.2.3, because you're starting to ship Orange Plus soon, aren't you?
Very, 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 very soon.
All right.
Just
so
a little hold up due to some political things that are going on that are causing shipping issues out of Taiwan at the moment.
All right. Is Sid on the call?
Sid is here.
Okay, so Sid, can you just go and check that the 4.2.3 has that? I don't remember that going in. Let me just look through. I don't see it. I don't think Cube Orange Plus is in 4.2.3. So we need a PR backporting that to the Plane 4.2 branch, which will then automatically make it to Copter. If you could get me that PR today against the Plane 4.2 branch, then I will be sure to include it in the final release of 4.2.3.
All right. Thanks for that.
Yep. Just send me a private message with the link to the PR later today. Be great.
Cool.
Anything else? All right. Well, thank you all for a marathon call, and thank you for the great questions. And best wishes to everyone in your remote ID journey over the next few weeks. We're here to help if you need to ask questions and things. Yeah, look forward to talking to you all at the next partners call in September, where hopefully a lot of you have already started, testing and getting compliant and all of those good things. So, any final questions before we wrap up? Nope. Have a lovely day. Bye, everyone.
Yeah, thanks.